Welcome to another episode of Chain of Thought, our podcast on all things scale AI research. On today's episode, we'll be talking about ResearchRubrics, a new benchmark from Scale AI that evaluates deep research agents. My name is Brad Kenstler. I'm the head of agent capabilities and environments research here at Scale AI.
I'm Calvin, and I work on evals here at Scale.
Hi, I'm Manasi. I'm a researcher working on GUI agents here at Scale with Brad.
Awesome. Well, let's get right into it. So I'm pretty excited about this benchmark, and I'll tell you why. I mean, deep research came out, it's been almost over a year, right? Like when the first deep research agents...
Close to like 11 months now, yeah, nearing up right on a year.
Yeah, and that for me really felt like the first killer app of consumer agents. Like, I mean, ChatGPT is itself an agent to some degree, right? But deep research is a specialized agent. And I remember when it came out, like using it for the first time, and I was like, wow, like this is going to save me a ton of time. And I've been a regular user of deep research agents ever since. I'm sure plenty of our viewers are as well. But I think one of the funny things about it is, even though it's been such a a compelling and widely adopted use case, like the benchmarks have truly been lagging. And so like we're now finally starting to see really high quality benchmarks to evaluate the capabilities of deep research agents, which brings us to ResearchRubrics. Manasi, I'm wondering if you could tell us a bit more about what ResearchRubrics is and what it evaluates.
Yes, absolutely. So ResearchRubrics, I think, as you mentioned, is a benchmark primarily to evaluate deep research agents. And it's sort of the first human-crafted benchmark in totality. So from the time that the tasks sort of are written to the actual rubrics being originally written as well as reviewed and refactored multiple times, humans sort of are involved with and drive each of those components of the benchmark. I think that's actually in contrast to some of the other benchmarks I'll talk about maybe in a little bit, where the initial sort of rubrics that might be generated are sort of generated by language models to begin with and sort of only reviewed by humans.
Right.
And it's also a rubric-based evaluation, which I've mentioned a couple of times, which means that instead of having just sort of one correct answer, because, as we all know, like deep research reports are extremely lengthy. Yeah. You sort of can have evaluations along many different axes. There could be correctness involved in the factuality of a response. There could be correctness involved in how the response, frames or describe or structures the communication quality of the response. And so you kind of have to evaluate along multiple different axes. And to be able to do that, we sort of use this approach of using rubrics, kind of like how you use, rubrics in school to grade an essay. Yeah. You can do that and apply that same framework to deep research agents. So I would say the two ways to sort of characterize ResearchRubrics as a benchmark is primarily it is a rubrics-based benchmark. So it has, between 20 to 40 different kinds of rubrics that evaluate a single task.
That's a lot.
As well as, yes, and we'll talk, I think, a lot about why you sort of need that much as well as the fact that it's fully human-crafted from sort of inception.
Yeah. I love this metaphor of like grading an essay from school because, I mean, that's in some sense exactly what deep research produces, right? Mm-hmm. It typically generates some kind of research or report. And so when you think about like how would you actually score such a thing where there's so much subjectivity and like different axes or dimensions that you would want to evaluate against, it seems somewhat obvious that like you need to have a holistic like rubric-based approach to evaluation. And I think like to your point, Manasi, like other benchmarks that have like previously been used for related tasks tend to look for like simple Q&A, like kind of finding a needle in a haystack, right? Like, what type of isomer does this particular chemical require for what? I'm not a chemist, I don't know. But you get the point, right? It's kind of like retrieving a specific answer and evaluating that. And I think we saw this with some of the earlier benchmarks that purported to evaluate deep research. It was more focused on like Q&A, precise answer finding. And this is more calibrated to how people actually use deep research and the types of responses that it provides. So on that note, Calvin, for the audience's sake, I'm wondering if you could introduce what a deep research agent is and how it differs from, say, traditional LLMs and like retrieval augmented generation, things like that.
Yeah, as you said, LLMs generally and a lot of the benchmarks test simple QA question-answer pairs, right? With deep research, it's very hard to sort of find the one correct answer. So, for example, if I were to ask today to a real estate agent, what is the housing market like in San Francisco? I don't expect a single answer. Right. I actually expect the real estate agent to dip into their knowledge, search the internet, do sort of like some synthesis of the information that they found on the internet, and maybe produce a long report with all the information about housing in SF. And this is sort of the same thing that deep research agents do. They look through sources live on the internet. They try to synthesize different sources into one specific very long report. And the difference between deep research agents and, for example, RAG systems is that RAG systems usually have some sort of database where they can retrieve information from, right? While deep research agents have to basically navigate the wild web to find information in the most obscure places to produce your response.
I'm curious, how it's the case that deep research agents, they use tools, right? Like, is that how they retrieve information?
Yeah, exactly. They have these two steps, right, that are fundamental. One is the planning steps. They have to plan sort of the steps they need to take to do the exploration and find all the sources, right? And then they do tool calls to be able to find these sources online on the web and then synthesize all of these in one coherent answer.
Yeah, I would say actually, I think to summarize it, it's basically like a few different components as well that you said. I think it's basically multi-step kind of like long-form interactions with tools to be able to browse the web. A lot of like reasoning capabilities also involved. So I think the backbone for almost all of these deep research agents is a very powerful reasoning model. I think for like OpenAI's sort of agents, I think it was like O3, for example, to begin with. And then the output, as I think Calvin mentioned, so these like very structured, lengthy reports can be up to like 30 pages long. And I think the like loop, as he sort of like mentioned, was to start off with planning and then kind of have this like maybe like loop that goes on for as long as you want, like retrieval and then reasoning and retrieval and reasoning. So you call your tools, you gather your information from these different web searches, you reason about it, determine whether you need more tool calls, keep sort of going in that circle until you finally reach the sort of all the knowledge you've accumulated. And then the agent's able to perform the final synthesis step, which is to like determine what part of that information it can keep in this final report to give to the user.
Yeah. And the agent is autonomously deciding when it's accumulated enough information.
That's correct. Yes. So it's not like an operationalized graph where like it's sort of structured like it can only do, let's say, 3 searches for XYZ keywords. It's sort of trained. I believe these agents are trained end to end. And so it's sort of up to the model how many searches it wants to do at what level.
Yeah. So that evolution, or like this notion of different kinds of deep research agents, I think we've seen this emergence of like fully autonomous reasoning-enabled deep research agents, whereas I think earlier on, and perhaps still in certain enterprise contexts, these may look like more structured deep research graphs, right? Where like each step is more or less programmatically driven. In fact, I don't know this for sure, but my suspicion was that the original deep research agent released by Gemini was this type of agent. It was much more structured, and then at some point they switched to an autonomous one. Because, I mean, that was the reporting at the time. And there was a significant improvement in capability. This was earlier on. Whereas I think ChatGPT or OpenAI's deep research agent from day one appeared to be fully reasoning and autonomous driven, which is like a key requirement for gathering enough evidence or information that is required for the report, which may require more steps or less steps than what could be pre-prescribed. So going back to the benchmark, Manasi, in this benchmark, we proposed this complexity framework. So can you tell me a bit more about that? I think we're talking about like the different kinds of tasks that someone might give to a deep research agent.
Absolutely. And I think it's something we thought a lot about was how do you decide what is an appropriate task for like a deep research agent to evaluate? Maybe like a simple one-step answer may not require, like so many levels of like web browsing. And so that was where the idea of like, how do you classify this deep research agent was born from. And so I think we thought a lot about like what the different axes are that might require sort of the synthesis of these long reports. And I think we sort of came upon 3. And the 3 are sort of conceptual breadth, logical nesting, and exploration capability. So conceptual breadth has a lot more to do with like how many domains or diverse topics are involved or need to be integrated for this task to be answered adequately. Whereas logical nesting is a lot more about sort of like how many sequential reasoning steps are involved in sort of answering the specific task. And finally, exploration capability. So some of these tasks may be very open-ended, and some of them might be sort of a lot more constrained. So to give some examples, I think for let's say for exploration, if you're asking it about a very specific answer about like a reasoning problem in math, you've already constrained quite a bit the problem space. So there's not a lot of exploration that the model needs to do itself to be able to fill in those gaps. But let's say you ask it a question about like, I'm trying to make a career change from software engineering. Give me some advice on how to do that. That's very open-ended. There may be some threads that maybe all of us commonly might think about, like, oh, what is, you can ask about give some advice based on your educational background and so forth. But it's kind of up to the model to fill in the gaps of what it thinks are the most appropriate topics to be able to reason about. Similarly, for I think logical nesting, you can have extremely sort of like tough problems. Let's say even humanities last exam might be a good example of this, where you have a lot of reasoning steps required to be able to solve a very tough math problem or a problem in chemistry. But that might not be super, like, doesn't need a lot of breadth. You don't need necessarily a lot of web searches for that. If you are doing a math problem, you might have all the knowledge that's given to you in the question itself. So I think we sort of found that these three were different axes around which you can kind of vary from like low level to high level around each of them, and sort of help provide like a framework to classify these kinds of tasks that may require a lot of web searches, only a few, may require sort of open-endedness or not, as well as like tough reasoning capability or not. And so you can kind of have tasks that have varying sort of degrees on each of them that can be thought of as like appropriate deep research tasks. Maybe we only want like, high on all of them. Maybe we only want simple on all of them. And so in our benchmark, we provided a lot of variety along each of those axes so that you can kind of determine what use cases might be the most reflective of your own to be able to, sort of understand the model's behavior accordingly.
Yeah, that makes sense. And just so I'm tracking this correctly, so like conceptual breadth, like an example of a prompt that would have like hard or like wide conceptual breadth would be something like, I want some report on like the potential effects of adopting a specific policy in this country if this country were to go into a recession next year and was part of some ongoing conflict. Those are like four different things, right?
Yeah.
And the agent would basically need to synthesize like knowledge about all these different things into sort of one answer that is that comprises all of them.
Exactly. Like maybe they have to think about sort of like health, economy. There's so many different like kind of verticals that might fall under an answer of like how is the country affected.
Yeah. And then in terms of logical nesting, these are things like, can you maybe explain a bit more about that? Like what like conditionals, like prompts where the final response from the agent is dependent on like some sequence of reasoning steps that it must take during the course of the task completion. Is that correct?
That's correct.
Yeah, I think, for example, for logical nesting, you can think about, I don't know, how you were solving problems when you were maybe in college, right?
Yeah.
There are some math problems that are extremely easy to solve. You can do one step and you get to the answer, right? And there are some math problems that require maybe you to consider different cases, for you to consider sort of different hops in logic, right? And the same sort of idea applies to these deep research agents as well. There are some prompts, like the one that you mentioned, for example, right, that might require you to consider different societal implications, different policy implications, and sort of do a search in the depth tree, right, and then trace back and do another search in another branch and so on, right? So that's a very nested prompt, very nested ask.
Or like maybe like another example is like for like very low not logical nesting is like, oh, just what's the capital of like a specific country? Like that's just knowledge that you need to have. Maybe there's like some level of reasoning involved in that, but very, very minimal. Versus something very high on sort of the reasoning or like the logical nesting sort of end might be to ask about like, put together an investment strategy for me based on current economic headwinds and stress tested against 2 or 3 historical scenarios. So not only does the model have to provide a complete investment analysis based on what it has to, first of all, understand are the current economic conditions, but also it has to sort of do a bit of reasoning about like what this investment strategy would be like in a completely different historical scenario with completely different variables. So there's a lot of sort of reasoning effort involved in that, and sort of the prompt itself asked it to do that, another 2 times.
Yeah.
So that might be a very high degree of logical nesting.
Yeah, and you can see like how each step of that is something that you need to independently evaluate. Like one, just the quality of the investment analysis, like as it would relate to what a professional might do. The second is the selection of the scenarios that you'd want to stress test against, right? Like, are these the right scenarios to pick, like relative to the context of what you are investing in, right? Or are they bad choices? And then, of course, once you have selected those, like how well are you actually applying those scenarios to the specific context of your investment? Yeah, that's interesting. So we talked a bit earlier about rubrics. So Calvin, tell me a bit more about our rubrics. So these are human annotated, right?
Yeah,
And this is something a little bit different in deep research benchmarks. I think there are other benchmarks where rubrics tend to be LLM generated. So I'm curious, like why do human rubrics, like what value does that provide relative to like synthetic rubrics? And just kind of walk me through our thinking behind that.
Yeah, so I think one first thing that comes to mind when you think about LLM versus human-generated rubrics, right, is that if you ask an LLM that might not be able to answer the question correctly to generate the rubrics for the question, then there's some sort of circular thinking there,
Sure, yeah.
or some circular argument, where most likely the generated rubric will lack in some places on sort of the minutiae that maybe a human could find, right? So I think you'd want a couple of things for good rubrics, which for now it still sits in sort of the realm of a human expert, right? Yeah. So first of all, you want strong guarantees and faithfulness with reality. So you want to, maybe if you ask a question about law, you want to reference the correct law case. If you ask a question about finance, you might want to reference recent reports that have been released by, I don't know, some financial institution, right? And generally speaking, to find this type of information and to understand what type of information to actually use, you still need humans who are very much involved in the field. Right. The second point is that you probably want to avoid sort of overfitting into some superficial themes, right? So you don't want to just say, oh, my rubrics is just a set of numbers that need to be satisfied. You want to actually look at how, for example, a financial analyst would write a financial report and the specific content that an expert would put into this.
So if I'm understanding that point correctly, I think it's an important one. If you're using model-generated rubrics, typically the approach is you predefine some prompt for the model to use when it's generating rubrics for a task. Yeah. And that is going to be formulaic, right? You will probably tell the model, I want you to generate 20 rubrics, and these are the categories that I want you to generate them in, and like here are examples of rubrics that might be good or whatever. And so what you're suggesting is that that approach, maybe it works in narrower contexts, but a better approach is, or might be, to leverage humans that actually have some knowledge in this domain and can credibly identify what are the things that are most important or relevant to include within some categories of rubrics. And they will bring their own perspective into the process that's informed on their professional experience.
Right. So in our benchmark, we had two main categories for the rubrics. One was explicit and one was implicit, right? For the explicit ones, you could reasonably think that the language models might be able to generate good explicit rubrics, right? But the implicit ones, you actually really need a human in the loop to help you define what are the sort of things that an expert is expected to give in an answer, right? But might not be explicitly asked. So another maybe somewhat stupid example is if I ask you about tourist locations in San Francisco, right? And I tell you that I want to be close to the sea, maybe Fisherman's Wharf is one of them, right? But maybe there are some gems that a local might have in their mind that a language model might not be able to give you. But they are somewhat implicit in the ask, right?
Yeah. So I think we'll get to the rubric categories a bit later, but just to pick up on that point, you're saying that there's some rubrics that are explicit, and so this is like an explicit rubric is the prompt asks for X and the rubric measures did you respond about X? So this could be something like, maybe the response is about the French Revolution, or the prompt is about the French Revolution, and it's asking for something about numbers of casualties for some key battles.
Yep.
That's an explicit ask.
Exactly.
And so you want to have rubrics that are, of course, deliberately checking for that. Whereas, let's say the prompt is something. Let's say the prompt is something about the French Revolution. It asks about casualties and key battles, and then also asks about the impact of loss of labor due to casualties in war to some local villages or whatever in France. I have no idea. This is a good question to ask. I'm just kind of coming up with something.
Right.
And so there might be some connections between the impact of wartime recruitment and enlistment, casualties, and how that impacts a local economy. And these are not explicitly called for in the prompt, but an expert that is looking at this would be like, 9 out of 10 experts that were answering this question would draw this implicit connection between these topics. Right. And so these are the implicit rubrics.
Exactly.
Yeah.
Exactly.
Okay.
So I think the point is we can have LLMs help us write these rubrics, but we still very much need human experts to be in the loop to help refine these rubrics. And I think more and more we're going to move towards this hybrid setting where you have humans and LLM collaborate to answer these sort of harder tasks that you might ask.
And yeah, I think we'll come to the results of the paper in terms of the breakdown with different categories. But I think, as Calvin has sort of mentioned, I think the models have become pretty, I think, at least fairly satisfactory at factuality. So they're able to tell when something is accurate or not. They don't hallucinate as much. They have sort of enough ample context with a lot of, let's say, especially for deep research agents, the web browsing that they're doing, to be able to ground their answers factually in factual correctness. But I think where the weakness is basically in the taste, so on and so forth, in understanding what context to put into an answer and what is irrelevant. And I think the deep research agents tend to struggle quite a bit with that. Meaning, if you use them to generate the rubrics to begin with, they may anchor themselves in certain areas and may not have rubrics that assess certain other areas, meaning that you sort of have a bias in terms of just anchoring in domains you're checking on, which is where I think humans sort of come very much in handy and are able to make those judgments a lot better.
Yeah, that makes sense. So if I recall correctly from the paper, we have two types of rubrics, mandatory and optional. And this is generally a rubric design pattern that we use quite a bit at scale. I'm wondering if you could tell me a bit more about what is considered mandatory and optional in this context.
Yeah, so for example, going back again to writing essays about history maybe, right? If the prompt asks for some information about World War II, right? A mandatory type of rubric would be to maybe tell you the dates of World War II, so maybe the start date and the end date, right? I think any answer should talk about that. Or maybe every answer about World War II should talk about Germany, right? Maybe a nice-to-have rubric would, for example, be talking about, how specific populations, specific European countries were doing during that period, right? So I would say the main distinguish between the two is some are sort of things that you would expect every answer to have. These are sort of the mandatory criteria. And the other criteria are the nice-to-haves. So things that could improve the quality of an answer, what would make an excellent answer, right? But the answer would still be satisfactory even if the criteria were not present. So these are sort of the distinctions of the two. And one important thing to note is that even when we look at the scoring, right, we would still want every single mandatory criterion to be satisfied for a response to be satisfactory. Maybe I'm repeating myself here.
No. It's an important point. And I think that what it allows for as well is, as an expert that is writing these rubrics in collaboration with other experts that are reviewing it, there are things that, again, you might have the perspective that an excellent report would have something like this. But it's not required, right? You can have a fully satisfactory report that doesn't have that, and a model would be justified in omitting it, right? Like maybe it's trying to be concise, right?
Yeah.
And so I think that's sort of the boundary between these mandatories versus these nice to haves.
Yeah, I think the mandatory criteria, I think the way that we imagined it, it's supposed to basically scope out like the minimum viable bare bones answer that like the points need to be present for it to consider like have answered the question.
Yeah.
But obviously there's a lot more that you could add to that, implicit criteria or otherwise that can make the response, a lot better in terms of both the coverage of things that it discusses as well as, sort of like connections or reasoning patterns that it draws between points that just make it a much, much richer response. And we sort of wanted to distinguish between the two because, for someone who's evaluating this, maybe some things are mission critical, right? Like there's something that, is super key that's missed. It's important to know whether it is sort of a mandatory criteria or it's something that, it's nice to have, someone can optimize for it later in their agent, but maybe it's not necessary for them to cover it to begin with.
Yeah.
So we wanted to separate that out. In our weights, we definitely had a threshold where we'd consider mandatory weights sort of 4s and 5s, while anything below that would be considered sort of the optional criteria.
Right. It's actually at that point, I don't think we've talked about this yet. Can you folks elaborate a bit more on like the evaluation methodology? So these are weighted rubrics, right?
Yep.
What did that look like? Like what was the scheme of how did we assign rubrics or weights to rubrics? Like how did we control for subjectivity, these kinds of things?
Right. So there's one thing that Manasi already mentioned, right? The rubric criteria, first of all, separate into mandatory and optional.
Yeah.
And for the mandatory ones, you would either assign a positive weight of +4 or +5 if it was something that you would want to be present in a response, or you would assign actually a negative weight of -4 or -5 if it's something that you actually want to avoid having in the response. And whatever sits in the range of -3 to 3 is what we call optional. So an optional positive criteria is something that would make the answer slightly nicer, but it's not necessary. And an optional negative criteria is something that would degrade the quality of the answer, but wouldn't make the answer totally invalid. So that's sort of how we thought about the weighting of the criteria.
Yeah, and so we're basically mandating that if it's mandatory, it needs to be a 4 or 5, and if it's not, it needs to be between 3 or -3.
Exactly.
Yeah, and I think you sort of asked like how do you sort of like control for like subjectivity.
Yeah.
I think we didn't do a human study yet where we sort of like had sort of analysis like how much variance there would be. Let's say 4 people labeled the exact same rubric, but what we did was like a sort of sensitivity study. So we sort of determined like if we vary the rubric weights, so what was labeled, let's say a 3, we now have it labeled a 4, or we have it labeled a 2. How much would the final scores shift? Quite a bit. So even if there were some people who had sort of mislabeled the weight of the rubric within margin of error, how much would it really affect the final scores? And I think we saw that we only saw I think a couple of points delta, maybe like 2-3 points delta. So I think the rubric framework itself seems to be pretty robust to at least that level of error, and would be able to at least gauge fairly accurately what the resulting quality of those model responses would be.
And that likely speaks to the value of having so many rubrics, right?
Yeah, that's correct.
Because your sensitivity to any individual rubric, being off by a couple of points in terms of weighting is lower, right? Yeah, that's interesting. On the rubric category, so just want to make sure I'm tracking this correctly. So there's mandatory and non-mandatory, which is also related to the weights. But then there are also just like qualitative categories of the rubrics, right? So I think there are like 5 different ones. We've talked about 2. Explicit rubrics being like a rubric that checks for something that was explicitly asked. Implicit rubrics being a rubric that is looking for some connection or like result that is, the agent needs to connect 2 different topics in a way that's expected. What are the other 3?
So I think the other, I think we actually have four.
Oh, four.
other
Okay,
ones.
I misspoke.
No problem. So we have the, as you mentioned, sort of explicit criteria. We have implicit criteria. Both sort of still deal to some degree with factuality. They check like the presence of specific facts, whether asked for or not asked for in the response. We also have synthesis of reasoning criteria. So these check a lot more for like kind of reasoning capability beyond just the facts.
Right.
Is the model's response able to make certain kind of arguments that, either are asked for in the prompt or not, but are they sort of able to connect between different sources? So if something happened in one country and something happened in another country, is the model able to draw a parallel between what might be similar or dissimilar, right? And so we sort of evaluate those kinds of arguments using the synthesis of reasoning criteria. We also have sort of references and citations. These are sort of for like very, very important sort of sources that need to have been addressed in that specific prompt for it to have been considered a satisfactory response. I think, as you mentioned, sort of like maybe like 9 out of 10 experts would agree that this source should be in a certain kind of response. So these might be like some canonical texts in sort of the out there in the web that need to be included in that response. If you're writing about Shakespeare, you almost certainly will want to address, some of his top plays. And if any of them are missing, then that's probably a pretty significant sort of missing reference or criteria. Or in RL, the sort of canonical textbooks, there are a few of them. And so I think we sort of use those criteria to target the kind of citation and source specific quality. We also have communication quality, which has a lot more to do with how the model frames its response. Is it appropriately formal? Does it use the appropriate kind of language? Does it use any kind of biased or toxic language? So any checks that have to do with not the content of what the response is saying, but a lot to do with how it's saying it will fall under the sort of communication quality criteria. And finally, we have instruction following, where if there's a specific request in the model, in the prompt itself or in the task, does the model adhere to that? So something like this might be like, is this a level in the prompt you might ask the model, frame this in the language appropriate for a 5-year-old or appropriate for a PhD student? And to be able to do that, that's instruction following. You might have a response which, again, factually is correct, but maybe doesn't adhere to that explicit request. And so we sort of have those kinds of criteria come under instruction following.
Yeah. Do we have any prompts or rubrics that were looking for an agent to respond in Klingon or Dothraki?
Not quite, but we had something similar.
Oh, really?
We actually had, and maybe I'm remembering wrong, but I think there was one prompt asking the language model to write something about a sequel for Star Wars in some specific style, and that was pretty funny. I think that was pretty entertaining.
Or something like that.
Exactly.
That'd be hilarious.
Yes.
But yes, that
cool.
would be an example of instruction following. Exactly. Asked to write about Star Wars in iambic pentameter.
Cool. So we have these rubric categories. We have these weights. We have mandatory versus not mandatory. These are a lot of different like things for the humans creating these rubrics to think about and potentially be biased about. So we have these rubrics, right, across all these categories, mandatory versus not mandatory. They're human authored. At the end of the day, though, when we're doing actual evaluations, we do auto evaluations using LLMs as a judge. I'm curious, how do we ensure that judges are reliable at doing this type of evaluation? Like, did we do any kind of study on correlation between, human results?
Yeah, we get all of our data, both judged by a human and multiple LLM judges, right? So what we look in the end is sort of the agreement between the human judge and the LLM judge.
Yeah.
And we study the macro F1 between the human grading and the LLM grading. We actually see a pretty significant agreement between the two. Of course, it's not perfect, right? There's still a small gap, but it's significant enough that if someone were to take our code and our data and try to run their own experiments, they can reliably use an LLM as a judge instead of going to human evaluators, which is just more time-consuming and just very expensive.
Yeah. That makes sense. And I think that more or less aligns with, the similar studies we've seen on other rubrics-based benchmarks, both from Scale and from others.
That's correct.
But I think it's part of also designing rubrics effectively. So one thing I thought was interesting about the paper is that we did a couple of ablation studies on rubric design, right? So we just talked about the alignment between human evaluation and judge-based evaluation. But there's also this question around how best to effectively design rubrics such that they are more performant under auto evaluation settings. An example of this, I think one of the things that we looked at was making rubrics more verbose. So perhaps you're adding more detail that's describing the specific thing that you want to check for, and maybe that improves judge efficacy in some way. And then the second one is we took a look at whether or not adding examples to the rubrics makes them more effective. And so this is the idea that, which as an example, let's say the prompt is something like, I want a report on the American Revolution about XYZ, and then one of the rubrics is the response must include a reference to 3 foundational texts from the American Revolution. Like that would be the default rubric. Whereas the rubric that has examples added to it would be the response must reference 3 foundational texts from the American Revolution, parentheses, e.g. The Constitution, the Declaration of Independence, and the Federalist Papers, something like that. So I'm curious, like, what results did we find in these studies?
Yeah, I mean, these two things actually seem very similar at first, right? But actually, the result that we found was maybe a little bit counterintuitive.
Really?
In the sense that they seem to be going in the opposite direction.
Okay.
Adding examples actually makes for a better judgment, so better alignment between the human judge and the LM judge, because basically it anchors both judges to some very specific things that to look for, right? But using a synthetic augmentation for verbosity or for like elaborating the rubrics more actually yields worse alignment between the human judges and the LM judge. And the hunch here is that probably the reason why there's worse alignment is that, again, we go back to the circularity of rubric generation, synthetic rubric generation again, right? So you might introduce biases
from the model.
Yeah. That might actually not be present if an expert were to think about certain problems.
Yeah.
So despite them being similar ablation-wise or like idea-wise, they're actually pretty different and yield opposite results, which was pretty interesting, I think.
Yeah. I think that, intuitively checks out to me. Like having examples helps anchor like what the frame of reference is, which sort of narrows the aperture a bit, both for humans and for models. They're both thinking in the same space. Whereas the verbosity augmentation, again, like you might have a rubric that is very concise, and actually that is ideal, right? And if you just take a model and just augment rubrics wholesale, you may have taken a perfectly good rubric, asked a model to augment it in some way by making it more verbose. And it's funny, you see this issue sometimes in using LLMs as a judge for like really complicated scenarios. But like if the model understands that the rubric is pretty good as is, but is being forced to like augment it, oftentimes it kind of just will add like filler, right?
Exactly.
Or like things that like might materially change the meaning of what the rubric means. So that's that it is counterintuitive that these things are pointing in different directions, but also the somewhat intuitive when you, I think, get into the details of what's actually happening here.
Yeah, after you think about it for a bit longer, it does make a lot of sense, right? But I feel like the first time I saw the results, I was like, does this make sense? And then, you think about it a bit longer and then there's definitely a reason behind it.
Yeah.
Also for like the examples, addition of examples, the correct answer may be in that list of examples. So it also constrains space for the model to be able to just check that very easily.
Right.
Instead of having to like determine like actually does this example fall under the specific rubric criterion.
Yeah. Yeah. So Manasi, getting to the actual results from the benchmark. So we tested deep research. We tested 3 deep research agents, and I believe these are all commercial agents. Can you tell me a bit more about them?
Yeah, so we tested 3 commercial deep research agents. This is Gemini's deep research agent, OpenAI's deep research agent, and Perplexity's deep research agents. At the time we were sort of doing this reasoning, I think there were only a few API options for these that had to come out.
Yeah.
So we actually did this by using the web or
The application.
the web application for each of these different models. And yeah, I think the overall interesting findings were in terms of actual results. Sort of Gemini had come out on top with about I think a 67 or 68% score. ChatGPT or OpenAI's model for deep research agent had sort of come very, very close at around I think 66%, a point or two lower, and then Perplexity's came quite a bit lower at around 56% overall in terms of the scores. And we also did an analysis of the breakdown of the failures of these rubrics, how many of these failed rubrics belong to each of the different categories, to try to get an idea of on average per task, out of the rubrics that failed, how many of them were explicit criteria, how many were implicit criteria.
Yeah.
I think we found that for an average task, out of all the failed rubrics, the sort of implicit criteria accounted for the large majority of the failures, around I think 50%.
Yeah.
And I think that sort of tracks with what we had sort of said earlier, was the failure sort of modes for these deep research agents are, I think, less and less about sort of hallucinating incorrect facts because they have such a wealth of context from the web browsing that these agents do. It's a lot more about the sort of the trade-offs that it needs to make on what are the sort of points to include in the response, and also what points may be missing, adequate context that adds important just adds important information that provides a richer response, more important background on what the actual answer may be. It may just be missing entire pieces of context, because in the deep research agent's search plan, oftentimes it may just go for what is sort of the most relevant few sort of papers out there, may not sort of know that there's another paper out there that may not sort of have a lot of lexical overlap, but may be super relevant and not include that information as well. So I think it has a lot to do with that the sort of points in the response that may or may not be included under implicit criteria. And also I think we found a little bit higher proportion of failure cases belonging to the synthesis of reasoning, which is sort of weaving different kinds of arguments into, sort of coherent responses, or drawing parallels between sort of different examples. Not just sort of listing out examples. This is something that we noticed more qualitatively when we were reading model responses, was deep research agents just oftentimes, may enumerate a bunch of facts without sort of, having a very strong argument drawing through each of them pertaining to sort of the task itself.
Yeah.
So I think those were, I say, the two bigger kind of chunks of the failure modes.
Yeah. That makes sense. What are the areas where the agents performed well?
Explicit criteria, I think, was surprisingly quite a bit, just very, very powerful. I think we only had maybe out of the criteria that failed, maybe only 20%, I think, were accounted for by these explicit criteria. And I think it really showed us that the strength of these models more and more is through factual sort of capabilities. They're able to ground themselves very accurately. They don't seem to hallucinate too much or sort of produce incorrect information.
Yeah.
So I think that was quite strong. Instruction following was very, very strong. We didn't see much sort of failure modes there. So if you explicitly ask the model to answer a certain way, it will sort of follow that request. I would say those two were probably the biggest areas of strength.
And I think the delta in the performance of different models, another interesting observation was also that it was probably somewhat due to the length of the responses. We noticed that Gemini was having very, very long responses, which basically gave the model more chances, more possibilities to actually get to the right answer and include certain things that the criteria were asking. On the other hand, Perplexity was giving shorter responses, and maybe was missing out on a few of the ideas that an expert would want to include in the response. And we did see some correlation between sort of score on the response and length of the response itself.
Yeah, that I'm going to circle back to that, because that's an interesting point. On the note about explicit versus implicit, I would say that this correlates well with my experience. I mean, I think I find that the more explicit I can be about exactly what I want deep research to provide me, the better. And I think part of this, at least for in OpenAI's case, it's sort of baked into the product experience, right? That's why they actually have that second step, which is like, here are the things that I can look for you. Can you tell me if this is right or not, right?
Exactly.
Yes.
It's prompting you to provide more
Constraints.
yeah, more constraints, more explicit, and be more explicit. And I think that power users probably are pretty explicit. Like, they probably figured this out, right?
Yep.
It's more general users or maybe folks that they don't know what they need to know in order to be explicit, right? Where you might see some degradation of performance. So that makes a lot of sense. On the length on the correlation between performance and length, that makes sense. And I think it's also something that just in general, length and rewards, right, in the training context is a big thing. And that's why you've seen these variants of GRPO as an example, where there's an explicit length penalty, where you basically weight the scores of response by the inverse of the token sequence length of the response. And so it's not surprising that you would see a similar effect in rubric-based evals, which might look somewhat similar to how one would train agents for deep research.
Yeah, and of course we try to control for this. So we also do include, as I said earlier, negative criteria that penalize models for including things that you might not want to include, right? I cannot just regurgitate Wikipedia and call it a day. That would not be a good response, right? So negative criteria kind of control for this. So you are not just at a huge advantage if you give a super long response. And indeed, there was some correlation, but the correlation wasn't the strongest that you could have.
Yeah. That makes sense. So on the topic of training, just as a brief detour, I'm curious, are there any insights that one could take from this benchmark and the results that we've shown, for someone that is trying to train a deep research agent using RLVR or using some kind of judge-based rewards?
Yeah, I think that's a really good question. I think a couple of things is one, I think as we've seen, we sort of have a couple of different ways to define deep research tasks itself, and we can maybe use that as a guide for different ways to improve the agent. I think one is the sort of core strong reasoning ability. And as we've seen, we have criteria that judge for strong reasoning ability in the rubrics themselves. And so I think you definitely need to start off with the strong reasoning model. So if your model isn't already sort of post-trained for reasoning, that's sort of the first step, I would say. For OpenAI, for example, their backbone would be one of the O series, reasoning models.
Yeah, and I think that again, this is just what's been reported, but I think that that tracks with deep research being a fine-tuned version of their reasoning models in general.
Yes, absolutely. But I think so the backbone needs to be sort of a strong reasoning model, essentially. So I think that's to start off with. The other sort of sides of it are I think there's kind of a mix of let's say it's SFT and RLVR. So I think you definitely want to make sure you can imbue the model with the capability to browse the web well, just in general, right? Even before you're sort of fine-tuning specifically on factuality or sort of specific rubrics, you kind of just need to make sure it is able to use web tools well.
Yeah.
And so I think maybe that's where distillation from more powerful models can help. And just generally sort of supervised fine-tuning on very high quality, naturally occurring sort of information seeking kind of queries, I think could be very strong to start off with.
Yeah.
Then,
just to add in, I think that point about bootstrapping capabilities is super important, and I think also somewhat dependent upon the deep research design. Because if I recall correctly, one of the not one that we tested, but there's another deep research agent product on the market, and they actually used a combination of API-based search and browser use search, which I thought was pretty interesting because it's if you think about there might be some information that the agent needs to collect that is not as easily accessible via standard APIs. And so you actually need to like spin up a browser instance to interact with it. And so like maybe having strong browser use capabilities is also like something that you would want to build on top of in enabling a deep research agent.
Definitely. I think, and that would help with like the other vertical in our sort of the deep research categorization for tasks, which is sort of conceptual breadth, right? The ability to like, make sure that you can sort of understand what sources to sort of search for, to how to synthesize, how to use these tools. And then I think the final component is maybe more on how would you like tailor the deep research agent towards understanding what criteria to satisfy or not to satisfy. And I think that's maybe where like RL or post-training can come in handy. We don't really have as strong like core verifiable rewards in deep research agents. As we talked about, the whole point of it is that they're like very open-ended and don't have a single verifiable answer like you might have in math or coding. But I think you can maybe use like different types of rubrics, either auto-generated, labeled, but as a sort of a proxy to be able to then get reward signals off of to do sort of the RL training. And that can maybe help with sort of the third vertical, which is the open-endedness or exploration vertical, which is determining like what information to put in, what information to put out, to keep out, and just determining sort of like how to optimize for like making sure you want to, adhere to the positive rubric criteria and sort of, not satisfy any of the negative ones.
Right.
And I think that's where sort of like RL with these rewards from rubrics that are sort of either auto-generated or labeled can help a lot. I think there's actually like a recent paper that came out from like AI2, like on Tulu's deep research agent. I think this is exactly the formula they followed. Was they started off with a very strong like base reasoning model. They sort of did, I think, like SFT on like very high quality sort of information seeking queries. And then they use this framework of like RL with like evolving rubrics, where these sort of like rubrics are auto-generated, but sort of use the up-to-date information on the web and sort of use that as a reward signal, do RL with that. And through that, they're able to achieve pretty good performance with their sort of like open source deep research agent.
Yeah. I read that paper too, and I thought that what they did was pretty smart. And I think that what I love about rubrics as rewards is that it enables end-to-end training. And again, I don't know this for sure, but it may have been the case that earlier versions of like, models fine-tuned for deep research are more fine-tuned for different components of deep research, like maybe information retrieval using search APIs and like pure reasoning as opposed to the end-to-end task. But today, with rubrics-based ROVR, like you can actually directly train on the end task that you're looking to do, which is really exciting.
So I think the reward generated by rubrics is also way more interpretable and way more controllable, right?
That's true. Fine-grained.
It's more fine-grained. So if you are a specific company who's fine-tuning their own model for deep research, and maybe you really care about just factuality and explicit stuff, you can basically zero out all the other criteria and just account for explicit criteria, right? So you have this controllability element of it, which is really nice compared to when you have a single answer and, that's the end-all be-all, basically.
Yeah.
Exactly.
Yeah, that makes sense. Cool. Well, last question before we wrap up. I'm curious to hear from both of you, like, what do you see as the next frontier for deep research agents?
I think there's one thing that emerged very clearly from our benchmark, which is models are very good at doing information retrieval, right? But we still really need to work on reasoning. And we've made huge strides in reasoning, right? And how we synthesize information, but we're still not there. So there's still a lot of work to be done there. And I think that will unlock much better deep research agents. And I think the second thing that I feel like is very important is to have deep research agents in maybe enterprises that can start using them with their internal knowledge base, and maybe they can actually start doing economically valuable work within these enterprises. And I'm very excited to see that happen maybe in 2026.
Yeah, I think I'll go off of that point specifically for enterprises. I think even you can sort of get a lot more direct feedback as well, not just from like sort of automated generated rubrics as people start to use these reports and provide more fine-grained sort of like interactions, feedback. There might be ways that you can sort of glean a lot of that information and be able to just see a lot more of how deep research operates in practice. I think I'm really excited for that. I think one thing I do think the next frontier of deep research would need to look at is a lot more in sort of like information like compression or like relevance within sort of like how much information can you put in like like a smaller amount of space within your response, like density, essentially, like information density. Which I feel like current deep research agents pretty severely lack. Either they're kind of maybe Perplexity's agent might fall into this category. They're quite short, but they don't have a lot of the informational density, so they miss a lot of the let's say explicit criteria. Or you have the other side of the spectrum, which is kind of maybe, let's say, Gemini's deep research agent, which are extremely lengthy. They cover a lot of explicit criteria, but they're so lengthy that they include a lot of irrelevant information that many users that we spoke to anecdotally, we've used these agents as well, have sometimes felt like obscures the kind of like information that they're looking for, because they don't really necessarily want to always have to read 30-page reports for something that needs to be maybe like a 4 or 5-page report. So I think there's definitely like a happy medium out there where you're able to, so let's say, maybe have like 5-6-page reports, but that are extremely informationally dense, such that you would sort of get exactly the information you're looking for. And you're able to sort of, not have any extraneous information clouding that. And you're sort of just able to dive right into it versus having to like manually search yourself.
And all that,
exactly. So I think that's probably going to be the next frontier where, you first solve the problem of how do I sort of get all the correct, factual information in my report. Then you sort of deal with the question of like implicitly, like what else do I need to include that the task doesn't ask me for, and finally, how do I like compress this so that this is as informationally dense as possible? And I think that would probably correlate the best with like human judgment.
I agree. So really solving that trade-off between concision and factual density.
Yes.
I think from my perspective, what I would love to see is deep research agents that have full analytical capabilities, as like agents that have access to, like, say, a Python environment with pandas and like access to data sets. Because one of the things that really enhances reports is rich visualizations, data analysis, things like that. So if I could like take the general knowledge synthesis capability of a deep research agent and add on this capability of like data science or data analytics relative to some like reference data sets, either internally or publicly available, such that the final report is like a PDF with like rich visualizations and analyses that are based off of statistics, like that would be really powerful.
Yeah, and I think we're starting to see this. I actually was looking at a few of the reports produced by Perplexity. They had some plots that were generated with tool calls. And I found it very cool. But,
so that's an area where Perplexity might be ahead of the curve.
I think they're already starting to work on it, but of course, I don't think we're there yet. So there's still work to be done.
Yeah. Great. Well, thank you both for joining the show. That ends this episode of Chain of Thought. If you have any questions or comments, please leave them in the comment section below. Thank you.